Hello everyone, my name is John. Thanks for stopping by my channel. Today I want to talk about a very important subject, one that I find very interesting anyway. And it was inspired by another YouTuber who runs a channel called Vertasium. I think his name is Derek Muller. Derek, if I got your name wrong, I apologize for that. But the name of Derek's video that he published within the last week is called The Big Misconception About Electricity. Again, his channel is Vertasium. And he talked about a few different things about electricity in there that are just absolutely essential for young people to understand about electricity. Derek does such a great job with his videos on all science because he reaches in and he looks for the most popular, currently accepted theories on just about everything. So you can't go wrong with that, but understand that theories can be wrong. 120 years ago, a very popular theory about the moon is that it was made out of blue cheese. Always remember that. Theories can be wrong, and often are. I'm going to say all theories are wrong. I don't think there's ever been a complete theory in the history of mankind. We're continuously building on everything that we know. Knowledge is the only thing in the world that moves forward in the universe. Everything else in the universe decays and is moving backwards. So just remember, we can get close to an answer, but never just swallow everything whole without taking a grain of salt with it. Back to Derek's video. Awesome. Go watch it. It's important. One of the things he said on his video, and one of the things that really made me inspired to come out here and say this very quick video here, in response to what he did, was he put out a question. How fast does electricity travel? We know that electricity travels at about 300 million meters per second. So if we had a 300 million meter circuit, okay, was his question, which travels a total wire that's 300 meters long with a battery and a switch on one side and a light bulb on the other side. After you turn the switch on, or close the switch in electrical jargon, how long would it take for the electrons from the battery to move to that light so many millions of meters of wire away? How long would it take that light to turn on? It's kind of a trick question. And I want to explain why I feel that way. This first diagram I'm going to show you is kind of like Derek's diagram, in that what you'll see is a 300 million meter wire with a battery and a switch on top, roughly in the middle, and a light bulb at the bottom. So on the left side of the light bulb should be about 150 million meters of electrical wire, and on the right side of the light bulb should be about 150 million meters of wire. And Derek's question was, when you close the switch, how long does it take for the light bulb to turn on? I think he was trying to get people to think that it would take 1 second, because the entire circuit is 300 million meters long, right? But he didn't count on this second diagram, which I'm going to show you now. Here you can see that the positive wire, the wire on the left side, is already connected to the battery. So that gives us a voltage potential, not just at the battery, but along the entire length of that wire. So the voltage potential for the positive side of the battery is actually at the switch, because that wire is already connected. And finally, this third diagram, you'll see that the negative terminal of the battery has a wire connected to it that goes to the switch. So we have full voltage potential on both wires before the switch ever is closed. Technically and theoretically, under my logic, when you close the switch, electrons start bouncing off of each other over the entire length of the wire instantly. So my answer to Derek's question is it takes 0 seconds to turn the light on. Now, there's a lot of variations in that answer that we have to consider. First of all, a 12-volt battery, 24-volt battery, whatever that battery is in that diagram, is not going to travel the length of 300 million meters. Electricity, current, the electrons, I agree with Derek that they do not flow in the copper or the aluminum or silver, gold, whatever the metal is inside that wire. It travels around them in a electromagnetic field, which is induced by the current, by the electrons floating after the current starts running. And that's how they can achieve a speed of 300 million meters per second. It's pretty awesome. Secondly, so we have to assume that this wire of 300 million meters is 0 resistance. And that's just a hypothetical. You'll never find that in the real world. But in theoretical world, that's where we start. We start with 0 resistance. Now that can't be true with a light bulb, because an incandescent light bulb like that can only light if the filament becomes hot enough to glow. So there has to be resistance in that filament. So in this diagram, everything but the light bulb and the battery is hypothetical, and it's not real world. So that's my answer to Derek's question. I want to talk about Bob Duhamel for a second, because he put out another video also on Veritasium's video, which, you know, Derek, it was awesome. Because Bob Duhamel's awesome too. He runs RSD Academy channel here on YouTube. And he was talking about Veritasium's question. Bob's video is entitled "Energy Doesn't Flow Inside Wires. Is Veritasium Wrong?" No. But Bob kind of produced a helper video to help you understand what Derek was talking about in his video. Very interesting stuff. I hope you'll take the time to watch both of those videos if you're interested in electric science. And I hope you'll hit the like button here on my video, just because I'm not a monetized video. I'm just a guy who loves science and dives into it. Electricity is not my field. No science is my field. I have a bachelor's of science degree, which means pretty much nothing. But I love science, and it's always been a hobby of mine. So smash the like button if you would, please, and come back every once in a while. I want to have a new video. Getting ready to do one on Ghost right now. Ooh. Thanks for stopping by, people.